So what we talked about yesterday is this here, this vertex form. A parentheses x minus h squared plus k, where h and k kind of gave us our vertex, and x equals h is the axis of symmetry. Yes? So if we look at this one here, so it might be easier to see it up on the board because the notes are a little small. Well, the vertex is our h comma k. H comma k. And when we look at this function here, h is inside the parentheses. So since we have plus 3, that means the value of h is negative 3, because when it comes out of the parentheses, we have to change the sign. And the value of k is just 4. And this is kind of helpful, because here on the vertex, we can go over negative 3 and up to 4, and that's our vertex. And when we look at the graphs, because on some of them, especially the homework assignment, it gives you 4 you have to pick from, that should be helpful, because that should be the vertex, where it's going to the smallest point or highest point. Now, the axis of symmetry, x is equal to h. I will abbreviate it when I'm writing it out. I didn't abbreviate it on the note sheet. I went on and typed it. But I'll abbreviate it A of S, axis of symmetry, is x equals h. Well, we know the value of h. It's negative 3. And it just goes straight through the axis of symmetry. Now, what we could do with this is from here make a t-table, x and y t-table, to plot points. Because the reason we have the axis of symmetry is everything along that axis of symmetry will mirror. It'll mirror across that line. So negative 3 is 4. If I wanted to, I could do negative 4 and negative 2 and plug those values into this function. 2. And it works out. If I plug it in, I will get 2 and 2. I'm just doing this quick, just kind of show if we plugged it in. And what I mean is I would plug into the calculator or do it by hand. Negative 2 parentheses, negative 4 plus 3 squared plus 4. Try this again. I'll move that down there so we have some space. This here. Well, negative 4 plus 3 is negative 1. Yes? Would y'all agree with that? Well, negative 1 squared is just is 2. So at negative 4, we would have 2. Now, as I said, anything on this line mirrors. So this point is 1 away from the line. It means on the other side, 1 away, is going to be the other point. It's going to mirror across this line. So we could get several points to the left of this line or to the right, and we could just count how far they are away from it. And it'd be going down. Now, instead of doing points, if we looked at the a value, it's negative, yes? When the value outside the parentheses, or the number in front of x squared when there's not parentheses is negative, it goes down. If it's positive, it goes. If you get confused on which way it goes, what can we do? Plug it into the graphing calculator. Because I can plug this into the graphing calculator, and it'll graph it for us. And that's what we did yesterday. You saw me work through all of these here, yes? So at this point, are there any questions on these here? We feel comfortable with these here, finding vertex and axis of symmetry? Yeah? We don't need to see another example of one of these here? Because it's pretty nice, because it's just looking at this function, h, k, vertex. Axis of symmetry is x equals the h value. Now, they will have something that looks like this here. F of x equals ax squared plus bx plus c. Most all of you have seen this formula at some point in your life. If you've walked in to the other math teacher's room and walked out the door. Above her door, she has the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 4ac. It's just a big formula above her door. It's talking about this here. This is what I call standard form of a quadratic. And we're going to use this because most of the time you're going to see it in this form over this form, vertex form. You're going to most likely see it in this form. Now we could use this here. A is the vertex negative 2AH will give us our B is equal to negative 2AH, so B is equal to this, so on and so forth. Luckily, this should be pretty big on your screen or on your paper. Yes? I'll have this here. Out of all of this here, vertex. The vertex is negative b over 2a, comma, f of negative b over 2a. Okay, I would make sure this is important for this part. I would make sure you kind of know where that is. The c value in that formula is the y-intercept. ax squared plus bx plus c. C is the y-intercept. Because what is the x value at the y-intercept? It's 0, isn't it? Because when we're talking about the y-axis, the x value is always 0. So if I plug 0 in for x, well, 0 times anything is just what? 0, yes? So if we look at this formula, anything with x on this side will disappear, and what is left? C. Isn't that kind of the same thing with linear equations? Y equals mx plus b. The b value was the y-intercept. So most of these higher degree polynomials, the number that's by itself in that formula will be the y-intercept. If a is greater than 0, it opens up. If a is less than 0, it opens down. The number in front of the highest term, the number in front of the variable with the highest term, if it's positive, it opens up. If it's negative, it opens down. And that works for even powers. Odd powers are different. We'll cover those later, okay? So for these quadratics, if the number in front of x squared is positive, it opens up. If it's negative, it opens down. If you can't keep that straight, what do? Graph it. Graph it. There's nothing wrong with graphing it. Okay? Questions on this here so far? Okay. Now this probably here looks a little confusing. Yes? Negative b over 2a and f of negative b over 2a. It'll be easier than what you think. So this is our function here. First one here. So it's hard to read on those note sheets. I'm sorry about that. The graph, so we want to graph 3x squared minus 6x plus 1. What do we say our normal function is? Ax squared plus bx plus c, yes? So a for our function is what? So it's just going to be the number, because x squared does match up with x squared, yes? So a matches up with 3. How about b? And c is 1. Move these down just a bit so they're not in the way. So we have this. A is 3, B is negative 6, and C is 1, yes? So we want to find the vertex, because we'll find it first. It'll make it easier to graph. Vertex, we said, is negative B over 2A, comma, F of negative B over 2A. So let's look at negative B over 2A. Negative over 2 times. I just plugged in for the values of A and B. We just plug them into that formula. So negative 6 is just 2 times 3 is? That equals 1. So for our vertex, negative B over 2A was 1. So any questions on how we found negative b over 2a? We good with that there? It's just plugging it in, isn't it? For a and b. C only affects the x-intercept or the y-intercept. So it doesn't come into play with this here. It doesn't come into play with this here. It just works out that way. It's kind of weird how it works. And we could see it going a little bit more in depth, how we can change this form to the vertex form. But I'm not going to focus too much on it because it's not overly necessary to understand this. So if we're good with negative b over 2a, now it's probably, now we need to tackle this f of negative b over 2a, yes? Well, what is negative b over 2a? We found that, didn't we? We found it to be what? 1, yes? F of 1. This should look familiar, shouldn't it? If you think back to Algebra 1, f of 1, or we're finding what the function's value is. That's all we're doing. So I'm coming back up here, 3x squared minus 6x plus 1. And I'm doing what? I'm plugging 1 in for x. So I'm going to do 3 times 1 squared minus 6 times 1 plus 1. And I'll scroll back down so it's a little bit easier to see. So we have this here. And I'll move it right here so we can see it and it's not over the top of the graph. Simplify. 1 squared is? Negative 6 times 1 is? Three minus 6 plus 1. Well, 3 minus 6 is? So what did we do? We first started off and found the value of negative b over 2a, which was 1, and then plugged it into the function. And when we plugged it into the function, we found out that it's negative 2. So our vertex is at 1, negative 2. 1, negative 2. Now we need to find the axis of, and that'd be x equals negative b over 2a. 1. That's it. That's all we have to do for this here. And again, it's not that it's over the top complicated. It's just we have lots of little. Now at this point here, we'd have to graph it. But again, graphing these won't be any different than graphing in vertex form. They just look different because we can do y equals and plug in 3x squared minus 6x plus 1. So again, you can type this into the graphing calculator and it'll graph it for you. Yes? Are we good with doing that, hopefully at this point? If not, come in for Flex and I will show you, or email me. I can send you a link to a video that'll go over how to plug it in to a graphing calculator, how to graph these. So let's look at this here. So A is 1, B is 2, and C is negative 1. When there's not a number written down, specifically written down, it's going to be 1. If they just have a negative sign in front of it, it's negative 1. So we're going to do the same thing. We're going to have our negative b over 2a. And then once we find that value, we plug it back into the function. It should be negative 2 over, which is negative 1. Now, if you're wanting, will the vertex always kind of be 1 and negative 1? Well, no. As we saw in some of the ones yesterday, they weren't just 1 or negative 1. We can have any number. It can be fractions, decimals, whole numbers. We can have any of them. We can have irrational numbers. But here it worked out to be negative 1. Now what do we do? X in our original function. So we'd have negative 1 squared plus 2 times negative 1 minus 1. I just took our original function in our two places where they were x squared and x. I plugged in negative 1. Negative 1 squared is 1. 2 times negative 1 is negative 2 minus 1. 1 minus 2 is negative 1, and negative 1 minus 1 is negative 2. So our vertex is negative 1, negative 2. And what would the axis of symmetry be? X equals negative 1. Axis of symmetry is x equals negative 1 because our formula says for this here, x is equal to negative b over 2a. Well, negative b over 2a was negative 1. So the axis of symmetry is x is equal to negative 1. So I didn't do this on the last one, but if we did the line, it would be this here. And because the value of a is positive, it would open up. And that's pretty darn close. It's not 100% accurate, but it's close. Any questions on this here? Are we good with these here? Yes? Do we need to see another example of one of these here? Yes? Okay. Let's find A, B, and C. So the value of A is, B is, and C is 1. Our vertex is negative B over 2A comma F of negative B over 2A. So what are we finding first? We're finding negative B over 2A. So we're going to have negative what? Negative 8 over 2 times. So we're plugging in our values of B and A. So we have negative B over 2A, so negative 8 over 2 times negative 2. Well, negative 8 is 2 times negative 2 is? So negative 8 became positive 8. 2 times negative 2 is negative 4. 8 divided by negative 4 gives, or negative 2, gives us negative 4.
You wrote negative 2 on here.
Yep. Oh, yep. If I'm thinking too much, I always get it flipped. So it's negative 2. Thank you. So the correct answer is negative 2, because 8 divided by negative 4 is negative 2. Got ahead of myself. Any questions on how we found the x value of the vertex? Did we also find the axis of symmetry by doing this? Well, yeah, x equals negative 2, and we'll write that up in a little bit. But now what we do is we take this negative 2 and we plug it in for x. So we get negative 2 times negative 2 squared minus 8 times negative 2 plus 1. We plug it back into the function to find the y value of the vertex. Now, negative 2 squared is positive 4. Negative 2 times negative 8 is plus 16 plus 1. We good with this here so far? Negative 8. Well, 16 plus 1 is? Negative 8 plus 17 is 9. It's 9. So the y value of the vertex is 9. Yes. Axis of symmetry is x equals negative 2. And then we can graph it And we can graph it kind of like we did the ones before. But that's it. That's it. That's all we have to do for these here. Questions on this here? And when you write the axis of symmetry, make sure it is set up as x equals 2 and not just equals 2. Because we're talking about the equation of the line, x equals 2. Now, the next slide is this here. Some of this is covered up. Don't worry about writing all this down. It's in your book, and we're going to worry about it later. The digital textbook? Yeah. No, I haven't handed out a book. It's the digital textbook you can get on Google or on Big Ideas Math. Minimum and maximum, what these are talking about is the vertex. If it opens up, it has a minimum value. That's the smallest y value we can have of that function. If it opens down, it is the largest value we have. And then we can talk about increasing and decreasing, the fact that the values of y as we go from left to right are going down and then they're going up, or they're going up and then going down. But I'm not too concerned with increasing or decreasing. Minimum, maximum value, I didn't include this, but I kind of just wanted to point it out and show you. Because what I want to focus on last is this here. So we're going to skip those two and look at this. And this here is really the intercept form, because P and Q are the x-intercepts. They're the values of x where this function crosses the x-axis, where it crosses the x-axis, where the value of y is 0. And the axis of symmetry is halfway between these two values. It'll be halfway between them every single time. And we'll have this here for the x value. And these here are our two symmetry points. Label the x-intercepts, vertex, and axis symmetry. So we're doing three things here. Now, we said this is ax minus p times x minus q is our form. The axis of symmetry is x is equal to p plus q over 2. And to find the y value of the vertexes, we have to plug it in. So kind of like what we just did with the other one, f of negative b over 2a, where we plug negative b over 2a in. But we'll see it here. This will make more sense. Now, the intercepts. This is going to be one of the easier parts to do. And the y value for the x-intercepts will always be 0. The y value for the x-intercepts will always be 0. Now, p and q are these two values right here. Now, if you notice, here they're minus, kind of like what we did with the vertex. The number that's coming out of these parentheses is going to be the opposite sign of what it is, yes? So here, since we have plus 3, it means it's going to be what? Negative 3. Comes out opposite of what we think. Here we have minus 1, so it'll be positive 1. It'll be positive 1. And those are our two intercepts. Negative 3, 0, 1, 0. And if I wanted to graph those, I could go negative 3, 0, 1, 0. Now, since these here are nice whole numbers, it's not going to be too hard to find the x value because, again, it says it's in the middle. So we've got 1, 2, 3, 4. So 2. Or let's find so vertex x is equal to p plus q over 2. What's the value of p? Value of q is, I'll write it down below. Because negative 3 plus 1 is negative 2 over 2, which is that's going to be in the middle. We add those two x-intercept points, the p and q values, together and divide by 2. Yep. Now, really, we're only missing one because the axis of symmetry is x is equal to -1. Because when we found the h value of the vertex, we found the axis of symmetry. When we find one of those, we find the other. Now, the last thing we've got to do is we've got to plug it back in. Bless you. Bless you. So to find the y value of the vertex, we got to plug it back in. Well, -1 plus 3 is 2. -1 minus 1 is -2. -2 times 2 is yes. Any questions on this here? All right. So we're going to look at this one here, -1/3 x minus 4 times x plus 2. And I think this one's written a little bit bigger than the last ones. Yes? Or no, that's same small print, the last two. So what we're going to do this time, so grab your graphing calculator. We're going to do this one by the graphing calculator. So to type in the fraction, we do alpha y equals enter. We'll have -1 over plus 3 parentheses x minus 4 close parentheses, open parentheses, x plus 2. So type that function in. Okay, did we get this typed in? Yes? Hit graph. So this is the graph, yes? Now for this here, we wanted to find 3 main things. We wanted to find the x-intercepts, the axis of symmetry, and the vertex, yes? So hit second table. Now the x-intercepts are the values where the y is 0, yes? Where the values of y are 0. Well, here's one, isn't it? -2, 0, yes? Because x is -2, y is 0. Do we see that one there? Intercept, -2, comma, 0. Because that's what it said. The x-intercepts are the value where y is 0. Let's keep scrolling down. 4, comma 0, yes? That's another one. So those two there are our two intercepts. We found them by looking at the table. Your table should be up already, yes? Because we're looking for where y is 0, yes? And we found them. Now, another way we can look at this and kind of get an idea where they are is when I look at the graph. I see I should have kind of one over here and one over here. And it kind of gives me an idea of where they're at. Now, the vertex, well, x is equal to negative, not negative b over 2a. It's our p plus q over 2. Well, we found p and q, didn't we? Because we found out that it's negative 2 and 4, yes? Plus 4 over 2. Yep. Well, negative 2 plus 4 is going to be 2, and 2 over 2 is 1, yes? Are we good with finding that value? Yes. So when we looked at this here, we took those values where the x-intercept, the values of x that made y 0, where x for y was 0, added them together and divided by 2 and found out that it's 1, yes? Well, looking at this table, hey, x is 1, yes? What's the value of y? It'll tell us it here, yes? Because if I know what the x value is, I can find the y. So that means our vertex is 1, comma 3, and the axis of symmetry is x is equal to 1. That'll do it all right here, yes? It'll do it for any of them, as long as we know. Second graph will give you the table. Second graph will give you the XY table. And looking at the table, because we plugged the function in y1, that first one, the y values for it will show up here. If I plug 8x into the second one and go second graph, 8x will be in the second one. Okay? So whichever one you plug it in, the y values will correspond to it. Does that make those a little bit easier? So when we find those values, this here will tell us. So we did the negative b over 2a, and we found out that negative b over 2a is 4. I could come over here 4 and find the number. Okay? So this here is helpful. It's a helpful tool where we can see these graphs. Any questions on this here? You good with this here? Yes?